Hey guys, I hope you're doing really well this week. Something a little different this week. I've made two changes to the way that I'm going to do the videos from now on. First of all, I'm going to scan in with a flatbed scanner that I just purchased, and that will hopefully save me some time. And second of all, I'm going to keep using the split screen method that seemed to get the thumbs up in the comments for working our way through the schematic. I don't have anything that needs repairing this week. All I've got in this week are broken screens, broken hinges, the usual rubbish. So I have nothing really electronically that I can work on for the channel. However, what I do have is a Dell Latitude 3500, which is what this is here. And what I'm going to do just for practice is work my way through the input section with the schematic. And hopefully it will serve two purposes. It'll give me some practice on seeing what the images are like on the flatbed scanner and working with the split screen. And who knows, somebody might have this Dell Latitude 3500 and it might help them start troubleshooting. So let's go. First of all, I just want to show you what the image looks like when I take it from the flatbed scanner. So this is literally me just putting the board onto the flatbed scanner and hitting scan. So this is a 3200 DPI image. If you see, this one turned out quite well. So this is the front of the board. So you can see there's quite a good level of detail. So this would save me having to take multiple photos of the board using the iPhone and stitch it together in Photoshop. So I think it's of good enough quality. That's the front of the board. And this is the back of that same board. Now, the back turned out quite well as well, but I'm just a little concerned as to how this section up here turned out. It just looks like it's starved of light a bit, and I'm going to work on that and see how I can improve it. But as you can see, for these components around here, the quality is good and will hopefully be usable, so that I can just do one scan and then it's done, instead of having to go to all the effort of joining all the images together. So let's go ahead. Just to clarify, this is a fully working laptop and all of these measurements are taken with the laptop powered on. So we're going to start at our DC in jack. So this is the DC in jack as it looks on the schematic, and this is it as it looks on the motherboard. So as you can see, we have 1, 2, 3, 4, 5, 6, 7, 8 pins, and that one has a little mark beside it. So this is pin number 1 right here. So I'm going to mark in those pins. 1, 2, 3, 4, 5, 6, 7, 8. And they correspond to, let's check it out here. So we've 1, 2 and 3 are connected together and they're connected to ground. Pin 4, which is here, we can follow along its path right here. So as we follow it up, that is our PS ID. So pin number 4 is our ID pin. And if you actually look at it more closely, you can see right here that it is not connected to any of these or any of these. It is going off on its own path. So that's the ID pin. Next we have pin number 5, and pin number 5 has an X on it, so pin number 5 is not connected to anything. And lastly we have 6, 7 and 8, and as you can see here, that is marked as plus DC in. So 6, 7 and 8 here are all joined together and they are our DC in. So the first thing I'm going to do here is I'm going to measure and see what the voltage is on pins 6, 7 and 8, because we should be getting somewhere around 19 volts at this point. So with my digital multimeter in volts, in a DC range and the 20 volt range, we're going to take a measurement. So I place my black probe to ground and I get my red probe and I place my red probe on either pin 6, 7 or 8. And when I place my probe here, I find that there's 19.45 volts on this part of the circuit. So that's good. That's in and around where it should be. The question is then where to go next. Okay, so if you look at the schematic here, we have pins 6, 7 and 8. DC in is here, but we're meant to be then connected to L4301 and L4302, and then connecting to a MOSFET here. However, if you look at the actual picture of the board, there is no connection here at all. There's a separation here, so this track here is not connected here, and it's not obvious where it's going. So what I'm going to do is I'm going to check the other side of the board and see if we can find where this comes out. I flipped over the board and zoomed in on the section around the other side of where that DC connector is. So that is around this area here. So my suspicion is that it comes straight through to the other side of the board. So the first thing I wanted to do was just check and see if the 19.45 volts was present. So with my DC multimeter in the 20 volts range, that's volts DC, I place my black probe to ground and place my red probe to this area right here. And what I found was that there's 19.5 volts at this point. So we've established that our 19.45 volts is coming through from our DC power connector onto this section here. So the next question was, could we locate these components? This is like EL4301 and EL4302. Now if you look at the top of this motherboard, we have EL4302, EL4301. However, I cannot see any inductors there. If I zoom in, I can't see anything there that looks like an inductor. So I think what happens with this, I think it's optional here. So you would have EL4301 and EL4302 here. However, on this particular board, it seems like they're just soldered across, that there is no inductor. But at least we know we're in the right section because it has the correct markings here. So we have our 19.45 and that comes through here and goes straight up onto this MOSFET right here. And if we look at the schematic coming through EL401, you can see that this hits the first MOSFET right here. We've measured 19.45 and it's coming the whole way along here to this first MOSFET. So one thing that you might notice on this is that the MOSFET on the board itself is marked as an AON 21321. However, if you look at that on the schematic right here, it's an AON 7403. So it seems like we have a different MOSFET than what was in the original spec sheet here. However, if I take a look at the two of those MOSFETs that I have side by side here, the AON 7403, which is in the schematic, is a 30 volt P channel MOSFET. And if you look at the AON or 21321, which is the one that is actually on the motherboard, this is also a 30 volt P channel MOSFET. So I don't know, maybe the factory ran out, but this is an equivalent, so it's no big deal. So this is the MOSFET AON 21321, a P channel MOSFET. So let's mark out the pins on that. So we have 3 source pins that are all together here. We have 4 drain pins. There's actually 2 bunches of 2, but these pins are all connected together. And then we have a gate pin right here, which controls whether the MOSFET is switched on or off. So if the voltage on the gate pin is low, that will allow the MOSFET to turn on and the 19.45 volts will flow from the source to the drain. So once again, in volts DC, I place my black probe to ground and I place my red probe to the gate pin. And I find that there is 3.1 volts on the gate. So that is low enough to turn the MOSFET on. And when I measure on the other side of the MOSFET, anywhere here you can measure, I find that there is 19.45 volts. So just to explain this once again, the 19.45 volts comes onto the source pins of this MOSFET. The gate pin is low, which switches the MOSFET on and permits the 19.45 volts to travel from the source to the drain. And I'm measuring the 19.45 here also. So following along on our schematic once again, we're through the first MOSFET and we're measuring 19.45 volts here. You can see on the schematic, this looks like 9 volt underscore AD, but there's a bit of a difficulty with this. You can see it here as well. There are some overlapping numbers. That's actually 19 volt. So we are measuring 19.45 volts at this point. Next in line is the second MOSFET. So as you'll see here, this is actually the same MOSFET as the first one. So it's an AON 21321. And similarly, On the schematic it's an Aeon 7403, but on this particular board it's replaced by a Aeon 21321. So it's the same pin outs on this one. It is 4 drain pins on this side. They're all connected together. We've got 3 source pins here, and we have a gate pin right at this point. So if the gate pin is low, the 19.45 will travel from drain to source, and we will see 19.45 volts here. So I take a voltage measurement at the gate pin once again, and I find that there's 1.7 volts on the gate. So this should switch the P-channel MOSFET on, and sure enough, when we measure the source pin of that MOSFET, we find that there is 19.45 volts on the other side of the MOSFET also. Now, after this here, we have our 19.45 volts here, which corresponds to this point right here. Now, it's referred to as plus SDC in right here, and as you can see, the gate is referred to as the plus SDC underscore in underscore SW for switch. So this is the switch for the plus SDC in. Now what I was looking around for here was to see where is our current sense resistor, but it seems like it doesn't exist, because there certainly are resistors in the configuration here, but that's a 100k, as you can see, that's a 10k, that's a capacitor, that's some sort of transistor, and this is a 100k. And anyway, our current sense resistor would be in series. So it seems like they don't have a current sense resistor after the 2 MOSFETs on this configuration. As we saw in the previous section, after our 19.45 volts comes through our 2 P-channel MOSFETs, it's referred to as plus SDC underscore in. Now, I searched the schematic for that, and here we have it, plus SDC underscore in. And as you can see, this appears to be our main power rail, which then goes out to all of our other secondary circuits to produce the other voltages. So our SDC in comes to this circuit here, which produces the 1.2 volts, which I presume is for the RAM. It comes to this circuit here, which produces our 1 volt for our CPU. It comes to this circuit here, which produces our 5 volt. And it comes to this section here, which produces our 3.3 volts. And as you can see, a number of the other voltages are derived from that 3.3 volts. So that's about it for this week's video, guys. Like I said, this is really just a bit of practice for me in using the software, and a bit of practice using my new scanner to see how I can produce images of the motherboards for the screen much more quickly. I think I need to do a bit of work on this. I'm not sure why that comes out, so I don't know, it just doesn't look good. Maybe it's just that the circuit is very, you know, densely populated, because it's a lot easier to see, you know, the components over here for some reason. I'm not sure why that is, but I'm going to try another board next week and see how it turns out also. But the one thing I can say is I can scan this in 3 minutes using the scanner. Stitching the images together was taking me, you know, hours to get it to the point where I could use it. So if I can get this scanner working for these images, it's going to save me an awful lot of time. So that is all I got for this week. If you have any comments or any suggestions, send them to me below. Also, if you have a motherboard that you're working on that you'd like me to take a look at, send me the schematic and pictures, and it might give me a bit more material for the channel, because I'm just not getting any material at the moment. It seems like as soon as you set up a YouTube channel to show how to repair electronic stuff, all that ever comes through your door is broken hinges and broken screens. That certainly seems to be the case for me. So if you have a laptop that you're having difficulty with and you can take good pictures of it and you have a schematic for it, send it to me and I'll see if we can go through it, and maybe it might make some good content for the channel. I'll see you next week.